Alright, in this video I'll be showing you how to complete the square when you're solving quadratic equations. So there's a little bit of work we've got to do. First we have to understand this concept of completing the square, and then we'll actually use that process to solve a quadratic equation. So first of all, let me get some ink here. It says here, recall that the quantity x plus 1 squared is found by multiplying 2x plus 1 binomials. In other words, that's what the 2 tells us to do, multiply 2 of these guys. And so all I did was FOIL that out, and you get x squared plus 2x plus 1. So we've actually talked about this in the past. There's a nice pattern here. And in fact, if you look at the 4 examples that I did over here to the right, there's a nice pattern that we have on the right here, on the right side. So first of all, these are what we call perfect square trinomials. So the question I have for you is, does that make sense to you that we would call these perfect square trinomials? Well, first of all, each of these has 3 terms, and each of them is equal to some binomial squared. And so that's why we call them perfect square trinomials. All right, so there's some patterns here I want you to be comfortable with and recognize. And the first one is, we can easily do these problems if we know the pattern. And so I would encourage you to see what the pattern is, or try to figure out what it is, and then do numbers 1 and 2. And then watch the video. Alright, so let's see how you did. So what you'll see here, if I just look at the bottom one here, x minus 4 quantity squared, notice if you square the x, you get x squared. If you square the minus 4, negative 4 squared is 16. And then what about that middle term? That's probably the hardest one to see. Well, if you just multiply these two numbers, negative 4 times x is negative 4x. And you double that, that's your middle term. Alright, so let's see how you did with number 1. So we're going to square the x. We're going to multiply 5 and x, and that'll be our middle term if we double it. And then finally 5 squared is 25. And so similarly on number 2, we can square the x. We can multiply these together and double, and we get minus 18x. And then negative 9 squared is 81. And by the way, it's good to be able to go both directions. We went from here to here, but you should also be able to go the other direction. There's a nice pattern there. You can see that going from 81 to 9, 9 squared is 81. Of course, x squared is the x squared, or x times itself is the x squared. And if you have this middle term, half of that is, well, half of the negative 18 is going to be your number here. All right, so let's go ahead and move on here. So next we're going to be completing the square. And so we have 2 terms here. And we want to add one other number here so that we create one of these perfect square trinomials. So the question is, what do I need to do to complete the square here? Well, so in other words, let's look over here. If we had x squared minus 8x, how could we come up with the 16 if we didn't have a 16 there? And in fact, it turns out that you can use, you can use all of these numbers here to generate these numbers here. So see if you can figure out how you would do that, and then start the video again. Alright, so hopefully you've got the pattern down. Notice if you look at the negative 8, if you take half of negative 8, which is negative 4, and you square it, you get 16. If you take half of negative 2, which is negative 1, negative 1 squared is 1. If you take half of 6, that's 3, and when you square the 3, you'll get 9. And so you can see that this works. Half of 4, when you square it, you get 4. And so that is the pattern. So let's go ahead and do number 3. So to create a perfect square trinomial here, we're going to take half of the 6 and we're going to square that. Well, that would be 3 squared, which is 9. Now remember, we should be able to go from this form, perfect square trinomial form, to writing it as a perfect square. So again, we found a nice pattern up above. We know that what goes here is going to be half of the number that's here, the coefficient of x. And so that would just be 3. It's literally the number that we squared to get the 9. All right, so why don't you try to do 4 through 6 and then check your answers. All right, let's see how you did. On number 4, you'll take half of negative 10, and that's negative 5. And when you square negative 5, you get 25. So again, half of the negative 10 is negative 5. That's what goes over here. Now, it's not like you couldn't multiply 2 of these guys out and double check that it's equal to this, but once you get comfortable with the pattern, you won't have any problem knowing that that's true. These are equal. All right, so let's see how you did on 5. You want to take half of 12, which is 6, and when you square that, you're going to get 36. And again, when we're figuring out what goes in the parentheses there, it'll be x plus, see, half of the 12 is 6, and again, that's what goes there. This number squared will always equal the number in here. And so one more time, we've got to take half of negative 3 on number 6 and square that. Well, negative 3 halves times negative 3 halves, we're going to get positive 9 over 4 when we multiply across. And so that's what we're going to have there, or add there. And so remember, it's half of this middle term that goes in the parentheses, and that would be negative 3 halves. All right, so now we're ready to solve some quadratic equations by completing the square. Now I want to point out something. We've already got 2 techniques that we've used to solve a quadratic equation. First, we solved quadratic equations by factoring, and then we were solving quadratic equations by using the square root method. Now on number 7, it turns out we could actually factor this, but that's okay. Sometimes, when we have a choice, we're going to take the easiest method, and factoring would actually be easiest here. But we're currently trying to learn how to do this technique, so you will run into some variety here. If you get a nice integer answer, then that tells you could have factored. But again, for now, our focus is on solving these by completing the square. All right, so notice we have 4 steps here that we're going to use. First, it says isolate the x squared and x term on one side. Now notice that's already done here. And then we're going to complete the square, basically on this binomial on the left here. And then we're going to write that perfect square trinomial in perfect square form. And then finally, we'll use the square root method to solve. All right, so let's go ahead and get started here. I'm going to go ahead and, again, first step is already done on number 7 here. So we're going to go ahead and complete the square. And of course, if we're adding something to the left, we'll need to add that same thing to the right. We know whatever we do to one side of an equation, we have to do to the other. So let's complete the square on the left. We know that we want to take half of negative 8 and square that. Well, that's negative 4 squared, or 16. And so we need to make sure we're adding 16 to both sides. So it's kind of strange. It's almost as though we made the equation more complicated looking, but here's the reason why we did it. We can write the left side as a perfect square. Remember, it's now a perfect square trinomial. We made it that way. And now we can write it in perfect squared form. It'll be x minus, remember, half of the middle term, so minus 4 quantity squared. And so this is equal to what we have above, but now it's in perfect squared form. And on the right side, when we add, we're going to get 1. So the whole point of this process is now we have an equation that we can solve. We have some quantity squared equals a number. We can use the square root method now. So I'm going to rewrite this and then take the square root of both sides. Don't forget, when you do that, you got to put that plus or minus in. And so when we take the square root of something squared, we're going to get what's inside, x minus 4. And of course, the square root of 1 is 1. And we do have plus or minus 1 on the right side. We'll add 4 to both sides. And so we get x equals 4 plus or minus 1. So remember, we're not done at this point because we actually have two answers when you see that plus or minus sign. The first one is 4 plus 1, which would be 5, and the other one would be 4 minus 1, which would be 3. All right, so now let's try number 8. If you think you got it, you might go ahead and try numbers 8 and 9. All right, so let's see how this is done. So look on number 8 here. We got to get rid of that minus 22 because we just want the x squared and the x term on one side. So let's add 22 to both sides. So now we're ready to complete the square. So I'm going to add some number to both sides. And so on the left, I want to complete the square and create a perfect square trinomial. So I'll take half of the 10 and square that. Well, that'd be 5 squared, which is 25. And so that's what we'll add to the other side. So now I want to write the left side in perfect squared form. That'll be x plus 5 quantity squared. And of course, on the right, we're just going to get 47. So now we have what we want. We have a problem where we can use the square root method. Let's take the square root of both sides. Don't forget your plus or minus. And so on the left, we're going to get x plus 5. And we're not quite solved for x. We need to subtract 5 on both sides. And so we're going to get x equals negative 5 plus or minus the square root of 47. Now keep in mind here that there's two answers. Negative 5 plus the square root of 47, negative 5, and negative 5 minus the square root of 47. That's what the plus or minus tells us. Now, on a test, I wouldn't necessarily, like if you're doing it written, I wouldn't require you to write it as two separate answers. I do believe when you do it in my math lab, you probably have to write out the two answers. All right, let's look at number 9. So again, we got to start the same way. I'm going to need to subtract 13 on both sides. And so we get x squared minus 6x is equal to negative 13. So I need to complete the square on the left, and whatever I'm adding on the left, I'll add on the right. And by the way, I like to use the little squares just because it's a visual of completing the square, but you don't really need the squares. It's just a Mr. Smith thing. All right, so let's go ahead and take half of negative 6 and square that. Well, that's negative 3 squared, or 9. So we'll add 9 to both sides. And now we can write the left side as x minus 3 quantity squared. On the right, we get negative 4. Okay, so let me rewrite this, and let's take the square root of both sides. On the left, of course, we'll get x minus 3. What about the right? Remember, if we're taking the square root of a negative number, that's going to be imaginary. You should end up getting x minus 3 is equal to plus or minus 2i here. We'll add 3 to both sides, and so we get x is equal to 3 plus or minus 2i. And I would just tell you, this I is almost like as if it were a variable like x. You cannot combine it with 3, or you can't combine the 2i with the 3. One is basically a real number and the other number is imaginary. You cannot combine those two together. We called the 3 the real part and the 2i the imaginary part when we talked about complex numbers. And so that is our answer. Again, you could write it as 3 plus 2i and 3 minus 2i. There are two answers here. All right, that's going to be it for this video.